All right, everybody. You're here today for my presentation on commissioning challenges with core and shell buildings. So I had a pain point with this over years, and I've always tried to overcome the challenges with it. So that's why I have this presentation. So that's not. So the course description is, in the commercial sector, developers build core and shell buildings with all required HVAC, and for the future building, once the tenants are there, they outfit the building with an internal space. By doing so, they become a challenge to multiple factors. Some factors are listed below. Core and shell building is designed to accommodate tenants of a perceived type. Any challenges of that type or account for occupants drastically affects the performance. So if there's other type of buildings, like if it's a lab building or something like that going in there, it completely changes the dynamics of that building. So the scheduling of the outfit for those tenants may not allow the building's mechanical systems to perform at all. So if it's a big building and on day one that they only have a small occupancy, that you won't be able to ever run your systems because of the short loads. Engineers, developers, and contractors only see their scope of work, not taking into account for full maturity of the building's construction. This presentation will go over examples that myself and other colleagues experience while designing, installing, or commissioning a core and shell building or tenant fit out. In addition to the historical information, I also will discuss what was done to overcome the challenges, as well as discuss the lessons learned with a good action plan and timeline. So first I'll identify what the core and shell building design options are. And I'll list and describe problems with core and shell designs, provide methods for correction and appropriate communication tools for owner and tenant education. Direct the owner developer to eliminate predictable problems. So first off, we have the core and shell is a cold, meaning that there is no HVAC at the unit or at the floors. So you have everything built out, just the shell, but you have none of the lighting, nothing else. Core and shell, gray or bare. So now you have there are no improvements. There's no walls, there's nothing else. And you don't have drywalls, ceilings, bathrooms, etc. So this is a little bit different from the HVAC part where it's cold, where you actually just don't have anything at all. Now you have dark, where meaning you have lighting is not installed. That's just for the lighting. Then you have warm, where you actually have the HVAC. Then you have vanilla, where you have the walls and everything else, and possible you'll have lighting, but you can actually see a floor being built out. So core and shell lit, this refers to the actual lighting, where they actually have the lighting installed. So here are some problems with core and shell. Test and balancing issues. They have commissioning test is limited. Sometimes you won't be able to test a system because you don't have the full system erected on the site. So unattainable minimum load. So if it's operating at minimum capacity, you might never be able to meet your minimum load at all. Mismatched design between the base building and the fit out, because each system is built by a separate team sometimes, and no communication between the two. Incompatible systems between base building and fit out. A lot of times you'll have a base building automation system that won't connect to the fit out automation system. So you have two run side by side. Poor or missing training for facilities. So they wouldn't know how to operate the building once it's fully, all the tenants are in there. Warranty issues. Sometimes you have something that's installed on the base building system that still doesn't have the warranty, or it's been sitting for years, and then when you start it up, it never worked. So the warranty's expired. Moisture issues. So if it's a cold shell, sometimes you might have moisture issues and you might develop mold in the system, in the spaces. Overlap or gaps with base building and fit out construction. So they might be toppling over top of each other trying to get the whole building done. And you might have the problems with them getting in each other's way, and so on and so forth. Base building performance, delivery temperature. So it might have been good when you commissioned it for the base building system, but whenever you start putting the tenants in and everything else, it doesn't work the way it's supposed to. Now, who's to blame? Because in construction, we always want to point the finger somewhere, right? So is it the architect's fault? No. They performed their scope of work. They just did the base building. Is it the engineer's fault? No. They performed their scope of work. Is it the general contractors? Not really. Subcontractor, test and balancing contractor, commission agent, owner. It's just the lack of foresight, actually, what it is. When the base building is balanced, it is balanced for day one conditions. There may be duct noise issues. So whenever you balance it, it might have been balanced to meet the CFM, but the feet per minute might be wrong. And that intrudes issues with duct. Fit outs are balanced as they are occupied without bothering with the base building conditions, resulting in an imbalance between the two. This continues to happen until the base building is fully occupied. So most cases, and I'll talk about it later, is I suggest that you keep on balancing the whole process through every fit out, and you're rebalancing the actual system, the base building system, as well as the tenant fit out. So I said that in the first one there. Design the building to have a smaller systems for fit out. So that's one way you can do it. Rather than have a large base air handling system, you have small systems in each floor level. And that's what you can lessen the impact. Continue communication between prospective tenants to be proactive if there are specialized systems in the future. For instance, if you have a prospect that's going to be a tenant and they want to have a lab in there, well, you need to start having that conversation day one. Ensure either some balancer or base building fit outs have the building balancer train the fit out balancer with lessons learned. So if you don't have the opportunity to have the test and balancers to be the core and shell and the tenant fit out ones, or at least give them some time to teach the new oncoming balancer of what they had problems with and actually lead them the way for their own fit out. Ensure the building and fit out balancer will have reports or commission agent for review. So you have to have the documentation so the next balancer or somebody else comes through. For buildings with central large area, it is difficult to verify the load capacity without load from the building. Sometimes it's impossible to test the equipment because there are no connected systems. So that goes back to the dark shells. an air handler that does not have the associated terminal boxes installed and the duct are capped off for each floor. So the corrective actions for it is identify the shortcomings in the design review. Communicate with the owner, the corrective actions. Retaining false load systems, that's another way we can do it. So for operating conditions and functional testing, so that's, you can put in load banks to start testing your system to verify that you actually have full capacity. Or you can defer the commissioning to when the fit outs happen. And that must be negotiated with the owner. Base building systems may be sized that they don't have the performance and characteristics for turn down ratings for day one. If they do so, the turnaround, even if they turn down, you'll have a problem with short cycling. So corrective actions is design reviews, discuss this operation and have more heating and cooling stages. So you can have, less nuances. Rent minimum load or heating cooling systems to operate until a minimum load can be achieved. So if you have a smaller fit out, you can pull in temporary chillers or heaters or boilers in the system. One particular project we had is pulling in temporary chillers and boilers, and they're placing them inside the garage because it was a 750,000 square foot building, and they're only going to operate about 25,000 square feet on day one. Many times the architect and the engineer is different from the base building and fit outs. As a result, a lot of the information is not transferred to the fit out architect or engineer. So corrective actions. Encourage the owner to have the same architect engineer for both base building and fit out. In instances where the design team are not the same, ensure that the base building team is available for lessons learned to answer questions. During the design reviews, ensure that the responsibilities for construction crew are clear. There should be some type of responsibility matrix that says who's responsible for what. Ensure that the designer is clear in the drawings and items that are existing to remain versus new versus relocated on the fit out. So that's the design for the fit out. Many times the architect/engineer designs the fit outs that do not meet capacity needed for characteristics to control needed. For example, I discussed earlier, if you have a tenant that has fume hoods, their valves might have too much static pressure losses for fans. Data centers don't have enough electric capacity. So if you have data centers don't have enough cooling capacity for the base building systems. Procedure rooms don't have 100% outdoor air systems. Base building systems operating schedules do not meet tenant needs. So corrective actions encourage the designers to engage with the owner and inform the possible special tenant requirements. As special requirements are known, design fit outs accordingly to overcome design mismatch. Upgrading capacity, modifying risers, walls, etc. Ensure that the schedule meet the tenant's needs. Many times the architect engineer designs incompatible systems for fit out that do not work with the base building systems. For example, both lighting and HVAC, during design reviews, you can identify the requirement of systems that are required and compatible. There might be a certain protocol, BACnet versus LAN versus Modbus, and they're not compatible between the two. You might need gateways and everything else to go through that. Encourage the design team in place the requirement specifications and drawings. During equipment reviews, check to see if the requirement is maintained. So you just check and see if everything's compatible throughout the process, and you try to do it through the design reviews and the equipment reviews. Training sometimes is overlooked. LEED Enhanced requires the commissioning agents to verify the training, but fit-out systems operation and sequence operation are unknown to the training that may not be effective. Corrective actions: coordinate with the design team to have the training for both base building and fit-out systems requirement within the design documents. Ensure the training is recorded and accessible for future reference. Some systems that start during base building may be sitting for a significant amount of time, and warranties expire before the associated operation. So corrective actions with this, we've done this several times on other projects, is encourage the design team place verbiage in the warranty after functional performance testing is completed. So it doesn't always happen, but you can have it in the specifications that the warranty starts once commissioning is completed. Encourage the owner to buy extended warranties for equipment. Ensure that dormant systems are not energized until they are close to the intended date of operation. If it's a cold shell, it is left too long without heating and air conditioning, there's a possibility of mold growth and requiring an abatement. Encourage the design team to move the cold shell to a warm shell to ensure the tenant fit out is very close in schedule. Encourage the owner to add temporary systems until fit out. Encourage the design team for central systems that has the ability for spaces to condition spaces independently of the fit out systems. It's common in commercial office buildings for tenants to elect to not install ceiling and just paint in the ceilings with a certain color. This makes it hard to identify equipment parts or locating equipment because you sprayed over the top of the nameplates and everything. So for corrective action for that, ensure the fit-out team requires that the labels are taped off before spraying. Coordinate with GC to ensure that the tape off actually happens. In commercial design, it is common to be confused as to what the design for the base building and what is for the fit out. There are cases when equipment is bought on the base building but not installed until the fit out. All too often, design teams are not clear on scope of work with the GC and subcontractors. There's also a gray area, i.e. a mechanical system is installed by a mechanical contractor, but thermostat wiring is missed. Encourage the design team to have the responsibility matrix in the design documents, both base building and fit out design documents, to encourage the owner to ensure that the base building and fit out designers coordinate. The question maintains will the base building system size to be efficient as correctly sized for future fit outs? So we discussed this before, because if you're designing for everything to be an office, that's completely different from a data center putting in or a lab or anything else. So sometimes you have to over design for that. Many office buildings have not been converted to multifamily buildings, so that's one thing. HVAC systems have been increased ventilation requirements, and that's nowadays everybody's increased ventilation. Encourage owners to direct designs with increased capacity and diversity. So anyways, we talked about it. it's through design reviews, it's through communication to the owner, and discussing how the building is going to be fit out and what the future use is for it. So it's a continued communication to get through there, and you try to be proactive through the whole system, and that's the best way to get through all the challenges.